Supernatural or paranormal is a claim that no explanation is ever possible for what you're trying to explain. And that's really, frankly, if you think about it, that's arrogant. For someone who is trying to be humble, like scientists, we say, hey, we'll take whatever evidence we get. And Mother Nature says no, then you know what? Gee, I guess that's our beautiful theory, murdered by ugly facts, as one person once put it. But claiming and clinging to the supernatural is a statement that your brain doesn't work. But if your brain doesn't work, then you can't make any positive statements about anything, including the supernatural. It's self-contradictory to make any claim at all. So we made this point once before. Christopher Hitchens has said, what can be asserted without evidence can be rejected without evidence. Another good quote that I like. Great TED Talk on how a haunted house actually turned out to be a house with a carbon monoxide leak, which mimics the symptoms people ascribe to feeling haunted. But Rick, I believe that belief system X is completely true. So if you tell me that, I will take you at your word. No argument for me that that is your belief. You're a better expert than me on what you believe. But if you make a statement about external reality, accessible to all, then if you want to convince others that it's true, you're going to have to demonstrate it with actual external evidence. Open systems and closed systems. So a closed system is one in which we invent the primary building axioms and building blocks, the logic pieces of that system. We invent all of them. That is a closed system because we invent all of them. And within that, yes, we can do proofs. So I'm thinking of mathematics, branches of mathematics. However, there's a big proviso here. The very appreciation that you have proved something will always remain this fuzzy, squishy light bulb feeling that we talked about early on. I mean, I could show you what to me is the most convincing proof ever on some mathematical theorem, and you could look at it and say, I'm not getting any light bulb here, Rick. I could have 100 people look at it and say, I'm not getting any light bulb either. You'd want to know why. I mean, if they're, let's say, as educated in the mathematics and so forth as the person who claims to get the light bulb, then it would be kind of strange. It tends not to really happen. But ultimately, I just want to get across the point that some people will put a little bit too much on the idea, well, it's been proved. But ultimately, there is this, what do we call it? This necessity for personal integrity. You have to have the sincere, honest, honorable desire inside yourself to really want to know what is the truth, that you're not just fooling yourself. To get a proof in something that you might kind of hope is not true, you definitely are going to need that. So reality is not a closed system. Reality is an open system. We don't define reality, we observe it. We wake up one day and we're 2 years old and we look around and we realize, wow, there's a world outside of, me and mommy's breast, okay? So I guess, gee, I'm feeling a little bit of curiosity here. I kind of want to know what it's all about. And off we go into growing slowly into adulthood. Yeah, so we have to observe reality, and we can not, therefore, make dogmatic fiats about what is true and what is not. Proofs are usually not possible in physics. Disproofs are possible. So if something requires logically that observation X produce blah, and then you go out and you do observation X and you get anything but blah, well, then that is a disproof, okay? So you don't know necessarily what's true, but you at least know that that's disproved. So science is pretty good at doing disproofs, but a final, irredeemable, nobody will ever do any better than this forever and ever proof, yeah, scientists are usually pretty cautious about making statements like that. Technologies improve and the depth and breadth of theories keeps improving, and who knows what artificial intelligence is going to come up with. And So people are usually, it's an open system. We have to be a little bit humble here, okay? Gödel's incompleteness theorems. I'm not sure I really want to pause on that here. It's kind of fun, but maybe I'll just at least state what it is. And it states that within a logical system, not all true statements are provable. Some philosophers are really, really upset about that and just can't quite wrap their acceptance around that. They are really bothered by that fact. But it is true. Not all things that are true are provable. And that's certainly true in physics. I can accept that pretty easily. Technology, for one thing, that's a very different thing from Gödel's theorems, but still. There's this other thing, though, and that's what I just talked about, and that is proofs are always going to rely on this squishy thing called your experience of the light bulb, and that's a biological thing. Not everybody's brains are equally built perfectly, and cosmic rays are coming in all the time, and, weird stuff going on. It's an organic thing that has to have its atoms replaced all the time, and you know how biology works. It's a messy thing, so it's always good to just measure the weight of evidence and have confidence in something, but it's usually not good to ratchet it up to 100.00%. Okay, this is all old stuff. I think I'm going to skip through here. There is an unfortunate tendency, I think, from some philosophers. They want to either put everything into we know everything with certainty and with minimal effort, or they want to put it into another category. We know nothing. The mind is just a tool of self-deception. But both of these are wrong, okay? The truth is somewhere in between. And it requires effort, and you can still make mistakes. And accepting that is just kind of, part of growing up. Logical fallacies. A logical fallacy is a pattern of reasoning that is consistently wrong due to a flaw in the internal logical structure of the argument. So here's a few. We're not going to go through all of them, but let's pick a good one here. I like this last one. Gas prices are cheap. As a percentage of the national debt, gas prices are far cheaper now than they were 50 years ago. I'm not hearing any laughing out there. You guys should be laughing. Oh, your mics are all off. Somebody type LOL or something. All right. I think that's funny. Okay, maybe not. So science is really the art of asking Mother Nature herself what's true. We're all scientists in some way if we know what's good for us. Clear thinking is a skill. It's a good habit. It's exciting. It's fun. And it's productive. Now, how you emotionally feel about the truth is another question, a different question. If you're confronted with uncomfortable truths, well, okay, that happens sometimes. It happens often. We'll first respond, as every healthy human being does, by experiencing our feelings. Wow, I really didn't like that. Really? That's the way it is? Oh man, really? I don't like that at all. That's not what I expected. Okay, so sometimes we have to go there. But you take those feelings and you place them off to one side, and then you ask the key questions. Okay, so that's how I feel about it. I don't particularly like it. But the real question, is it true? What's the evidence? Does it fit with well-verified knowledge that I have or can gather? How can I energize and raise my awareness and engage my desire for clarity here? Those are the right questions. Some of us may have stranded along the path, however, of personal growth. I can't even see my total screen because of all these, shoot. I don't want, here, let's put that there. I don't want to hide my screen. Some of us are stranded on the path of personal growth. We may have instead reacted only from our feelings which may proceed from our biases and be unconcerned with truth. Maybe you've seen that in other people. It's kind of unpleasant to run across. So here's another great quote from Carl Sagan. In science, it often happens. You know, that's a really good argument. My position's mistaken. And then they would actually change their minds, and you'd never hear that old view from them again. They really do it. It doesn't happen maybe as often as it should because scientists are human and change is sometimes painful, but it happens every day. I cannot recall, however, the last time something like that happened in politics or in religion. And I have to agree with Carl Sagan on that. I give lectures, and on almost every subject I'm often asked, do you believe in UFOs? I'm always struck with how the question's phrased, the suggestion that it's a matter of belief and not evidence. I'm almost never asked, how good is the evidence that UFOs are alien spaceships? And then from Richard Feynman. For successful technology, reality must take precedence over PR because nature cannot be fooled. The wisdom of non-attachment. Okay, so some people might think that scientists are just a bunch of, wet blankets. They just throw cold water and everything, and they turn everything into Spock. And no, again, Spock is not my hero. The wisdom of non-attachment has been discovered by ancient and modern people living in the Taoist and the Zen tradition. Okay, inner peace comes from non-attachment. Non-attachment does not mean indifference. It means focused awareness with deliberate deflection of critical self-judgment and egotism. Okay? You are focused only on the awareness itself and not on judging yourself or judging somebody else or your ego. It's a great place to be. It's okay to acknowledge, I don't know. Be clear on what you know, what you don't know, and what's still not understood. Being able to firmly put an idea into the category, gee, I need more thought. I need more investigation to make a judgment on this one. Perfectly good. Being awake and aware is a good thing. This is another good place for a good laugh. What about these people here who grabbed one of the phone numbers? I guess they can't distinguish between a scientific study and a kidney harvesting scam. Every time I see this cartoon, I think of this X-Files episode that was about that. Ugh. Anyway, so this is a good place to be. Not a good place. Okay, let's make sure you get that. Good, not good. Good, not good. Everybody got that? Okay. 3 primary modes of representing reality in internal experience: visual, auditory, and kinesthetic. So here's something else that bothers me a little bit, and that is the tendency, unfortunately, that has crept into education to try and convince people that they have only one mode that they are good at, and that is up to the job of teachers to bend their teaching to agree with your one mode. But in fact, what's true is that there are different ideas, different areas of inquiry that are suitable, more suitable for some of these than others. So for example, if you're going to learn science, science is an understanding of the real physical three-dimensional world and how it evolves in time. The equations of physics are equations of location and time and the fields that exist within them, temperature and electromagnetism and so forth. It's naturally going to be best understood by using pictures. Sounds are usually not as useful, although they may have their place. A visceral sensation, your proprioceptive system of where your body exists in space, is usually not that useful. Although in gravity, I think it is useful. But okay, mostly in astronomy, visual. If you're going to study music, however, I would say the auditory sense is going to be the one that you're going to want to keenly develop and get very practiced at. If you're going to learn a difficult sport like gymnastics, then I would say your kinesthetic sense is going to be the one that you're going to focus on. Pictures will help only a little bit. Sounds probably not at all in gymnastics. and then kinesthetics. Okay, so you want to practice all three, and don't let somebody pander down to you and have you convinced that, oh, I'm sure you can't learn to be better at X and Y, but maybe you're best at this, and that's what everything should be bent to. You're really selling yourself short. Don't do that. I don't want to see people selling themselves short. I want to see them expansive and growing and getting better and learning and, mastering new things. That's what's fun. So what is science and what is it not? Well, one thing that it is not is big equations. I mean, that doesn't define science. There are obviously areas where big equations are necessary, like this one, the Navier-Stokes equation. And that's physics and astronomy and places like that. But it doesn't define science. And Hollywood stereotypes, that doesn't define scientists either, or evildoers. The essence is really simple. It's asking Mother Nature herself, what's the truth about things, rather than your wishes or your prejudices or being, too dogmatic. Okay, you want to be willing to accept her answer, her with a capital H, Mother Nature. The art of science is to find out how to ask her as carefully and revealingly as you can muster. This is also true in the softer sciences as it is in the hard sciences. So a tricky and subtle science like psychology, okay? Still, if your sincere desire is to know the truth, then you can buckle down and try and handle the challenges of confronting your biases and self-made blind spots, at least to some extent. So scientists, they're just good, regular people, like my buddy Stefan here, who's a professor of astronomy at Queen's University in Canada, or this rock star who's also a Harvard biologist, or Emily Schuckberg, who's head of the British Antarctic Survey, climate scientist, or David Newman, MIT professor of astronautics, or, oh wait, these are just actors. Oh, I could have guessed that. Look at those faces. Talk about posers. Now that guy looks like a scientist, okay? A little bit nerdy, okay, but 2 thumbs up. Oh my God. But, look at the equations on the blackboard, so he knows his stuff. Cara Santa Maria, graduate degree in neuroscience, great writer, and has a program well worth listening to. Neuroscience, very interesting for everybody. Beth Brown, specializing in the high energy universe using satellite missions. Sylvia Torres Pembert, okay, so astronomer, International Astronomical Union. That's the International Society of Astronomers. The American Astronomical Society is kind of the main society for American astronomers. This is even bigger. It's the International, the IAU. Former president, specialist in chemistry of nebulae.